While this morsel refers to HPC-related networking topics, that's not to say that these topics apply only to HPC systems. The following topics are all used in the main field of computers, but they are of particular importance for your HPC computing tasks. This also serves to clarify that there are not really many unique services or technologies that are exclusive to HPC that are also not generally used in mainstream computing. The first topic is SSH. SSH stands for Secure Shell, and it is a remote administration protocol that allows you to connect to another server over the internet. It's encrypted and is actually quite powerful, allowing you to do advanced activities such as tunnels and X11 forwarding. You will use SSH extensively, and it is an absolute must to be familiar with this when using an HPC system, although it is also used extensively outside of the HPC realm. Its default port for SSH is 22. Another popular service which is frequently used in a large HPC system is DHCP. This is a service that is regularly used in most managed networks, and it stands for Dynamic Host Configuration Protocol. DHCP issues an IP address to a device so that it can communicate with other devices on that network. DHCP is also used for advanced network features such as pre-execution environment or PXE and network booting, which we will talk about in a later chapter. A DNS or domain name server is used to take words and resolve them to the unique internet IP addresses that computers use to identify servers. For instance, 1.1.1.1 or 8.8.8.8 are IP addresses for some very popular global domain name servers that have a register of internet names and their associated IP addresses. DNSs exist to help humans to remember addresses more easily. You will find it's much easier for you to type in www.chpc.ac.za instead of 197.221.55.74. A DNS's job is simply to take the words and convert them into the IP address equivalent. When you convert a word to an IP, it is called a forward lookup, and I always use the mnemonic forward is 4 words. And if you convert an IP to a word, it's called a reverse lookup. In an HPC environment of possibly hundreds or even thousands of computers, it is much easier to refer to compute node 456 than it would be to try and remember the IP address 192.168.1.226. A static route is also a common networking approach that is likely to be encountered during your lab sessions. In networking, it is common for the route from source to destination to change dynamically depending on the network load and the status. Since there are many different systems between a source and a destination, it is possible that one link might go down and another, less preferred route might have to be the only option to get to the target. A static route simply makes sure that the route taken does not change. It is hard-coded, and it reduces the router's overhead that is typically associated with dynamically trying to determine which route to take. A network firewall controls network traffic, and it regulates what is allowed into or out of a network. A firewall is configured manually, and the best practice is to blacklist everything, that is, not allow anything, to deny everything, and then manually permit what you want to be accepted as an exception. There are various forms of firewalls, but the most important thing to understand is that a firewall provides security on a network, but it is often the source of undesired network behavior, for example, blocking an application or a network port that you need to work. Although you might be advised to disable a firewall in a test cluster, it is just not a good idea to do that in a production environment. A quick and nasty trick whenever you have a network communication problem is to disable the firewall and to run your test again. If it resolves the second time, then you know that your firewall is likely to be blocking the port. But always remember to switch your firewall back on when you've finished your tests. And remember, every device has its own firewall. NAT stands for Network Address Translation. In plain English, this manages multiple internal network communications with external devices, mapping an internal private IP address in such a way that it can talk to the internet. Ping is a tool for testing a network connection, provided that the firewall on both sides, that is, the source and the destination, allow the ports open for ICMP. A source sends out a ping and waits for a reply. If there is a reply, then you can be certain that the two network devices are successfully communicating via TCP/IP. If there is no reply, examine the error message carefully and try to figure out what the issue is. Here are a few examples of some of the common issues with a failing ping. As an aside, ping can also be used to conduct some basic performance metrics on your network.